Welcome to our channel. This video is available in 2 languages. Hear the English version. We hope you enjoy it. Subscribe and stay with us until the end of the video. Stars are among the most fascinating celestial bodies in the universe. These giant nuclear reactors shine for millions or billions of years, illuminating the universe and providing energy essential for the formation of planets and life. Examining the birth, evolution, and death of stars provides insight into fundamental cosmic processes and the history of our universe. Their influence extends far beyond their own existence, influencing the formation of galaxies, planetary systems, and even the chemistry of life on Earth. Stars are born within nebulae, enormous clouds of gas and cosmic dust distributed in interstellar space. Nebulae represent the raw material of the universe from which stars and planetary systems form. They are divided into several categories. Emission nebulae. These nebulae shine thanks to the radiation emitted by ionized gas from nearby stars, which excite their hydrogen atoms, causing them to emit light. An iconic example is the Orion Nebula, M42, visible to the naked eye in the constellation of Orion. Reflection nebulae. These reflect light from nearby stars and appear bluish due to the scattering of light, such as the Witch Head Nebula. Dark nebulae, dense clouds that block the light of objects behind them, such as the famous Horsehead Nebula in the constellation Orion. These regions are often cold, with temperatures as low as a few tens of Kelvin, creating the ideal environment for gravitational collapse to form new stars. Within nebulae, small gravitational perturbations can trigger the collapse of dense regions of gas and dust. These clumps, called Bok globules, begin to contract under their own weight, gravitational contraction. During this process, density increases rapidly, generating friction and heat. Clusters, called protostars, are formed, surrounded by protoplanetary disks in which planets will develop. As the contraction continues, the pressure and temperature in the core increase until the conditions necessary for nuclear fusion to ignite are created. When the core of the protostar reaches temperatures above 10 million degrees Kelvin, the first hydrogen atoms begin to fuse to form helium. This process of nuclear fusion releases enormous amounts of energy in the form of electromagnetic radiation. It also generates radiation pressure that balances the gravitational force, stabilizing the star. At this point, the star enters the main sequence of the Hertzsprung-Russell diagram, which we will see in an upcoming video, a phase of stability that can last billions of years. The main sequence represents the longest phase in the life of a star. During this period, the fusion of hydrogen into helium in the core provides the energy needed to maintain hydrostatic equilibrium. The characteristics of stars in this phase, main sequence, depend mainly on their mass. Low-mass stars, red dwarfs, they are small and cold, with surface temperatures below 3,500 degrees Kelvin. They live for hundreds of billions of years, burning hydrogen very slowly. An example is Proxima Centauri, the closest star to our solar system. Intermediate-mass stars, like the Sun, they burn hydrogen most rapidly, with a lifespan of about 10 billion years. At the end of their lives, they become red giants. Our Sun is the best example of this category. Massive stars, they burn through their nuclear fuel in a few million years. They are extremely luminous and end their lives in supernova explosions. A famous example is Rig-Hel, a blue supergiant in the constellation Orion. When the hydrogen in the core is exhausted, stars enter a phase of instability. Nuclear reactions move to the outer layers, while the core collapses and heats up further. This leads to outer layer expansion. The star transforms into a red giant or supergiant. Betelgeuse, a red supergiant in the constellation Orion, is a spectacular example of this phase. Fusion of heavier elements. In massive stars, fusion continues with elements such as carbon, oxygen, neon, and iron. During this phase, stars lose a significant portion of their mass through stellar winds and pulsations. This material enriches the interstellar medium with heavy elements, preparing it for the formation of new stars and planets. The Ring Nebula, M57, is an example of a planetary nebula formed by the mass loss of a dying star. Low to medium mass stars, like the Sun, end their lives by expelling their outer layers, forming a planetary nebula. The remaining core becomes a white dwarf, a dense, hot object composed mostly of carbon and oxygen. White dwarfs are similar in size to Earth but incredibly dense. They slowly cool over billions of years, eventually becoming black dwarfs, a hypothetical fate not yet observed. An example of a well-known white dwarf is Sirius B, the companion of the brightest star in the sky, Sirius. Massive stars end their lives in spectacular supernova explosions, releasing enormous amounts of energy and enriching the universe with heavy elements. They can leave a remnant in the form of a neutron star, an extremely dense object, with a radius of a few kilometers but a mass greater than that of the Sun. An example is the Crab pulsar, a remnant of the supernova observed in 154 AD. The neutron star emits regular beams of radiation and is located in the Crab Nebula, M1. If the remaining core is massive enough, it collapses further to form a black hole. These extreme objects have such intense gravity that not even light can escape them. They affect their surroundings, attracting matter and distorting space-time. A famous example of a black hole is the one located at the center of the Milky Way, Sagittarius A, with a mass of about 4 million suns. Astrophysical importance of stars. Stars are essential for cosmic evolution. They produce chemical elements necessary for life through nucleosynthesis and shape the structure of galaxies. Their life cycle links the formation and death of celestial objects, ensuring the recycling of cosmic material. Studying the stars allows us to understand the origins of our solar system, exploring the formation of life in the universe, analyzing extreme phenomena such as supernovae and black holes. This stellar exploration highlights the complexity and beauty of the cosmos. By analyzing familiar stars such as the Sun, Betelgeuse, Proxima Centauri, and Sagittarius A, we can expand our understanding of the universe. Thanks for staying with us until the end of the video. Remember to subscribe to the channel to stay updated with new content that will be released. If you liked it, add a like to the video. See you in the next video. Bye.